Alrighty, so this is our last lesson of Unit 7, okay? We are doing elliptical word problems, okay? I'm continuing with worksheet 7-7, okay? So there's the last 4 that we're going to be working on. Your homework is similar to this. I will post the questions from the textbook as well as, the answer key is posted to Schoology, so you can check that. If you've already turned in your textbook. If not, then you can just use your textbook. And then this will be the last assignment from the textbook, okay? Our next unit will be from a packet. All right. So an arch, right, is in the shape of the upper half, so it's semi-elliptical, right? Half of an ellipse is used to support a bridge. So it looks very similar to the bridge that we had here with the parabolic shape, except now this is just an elliptical shape, okay? So it's a little bit wider, all right? It spans a 24-meter river, so there's like a little river underneath here, if you will, okay? And this is 24 meters, okay? And at the center of the arch, right, the bridge is 8 meters high. So that's 8 meters, okay? Write an equation of an ellipse in which the x-axis coincides with the water level, okay? And the y-axis passes through the center. So what they're basically giving you a hint there is, and this is what you're going to see in most of the word problems, is the center, right, is going to be right there, where this is going to be your major axes. This is going to be half of your minor axes, okay? Because if I extended this and put the full elliptical shape, this would be shorter, right? So this has to be my major axes right there, okay? Now, since this is at the center of 0, 0, right? So they're saying this is your x, this is your y axis. The center is 0, 0. Therefore, it's just going to be x squared plus y squared equals 1, okay? And then, like we just discussed, okay, 24 meters, okay, is your major axes, right, which is 2a, which I saw in some of your papers. Or another way to think about it is the distance from the center to a vertex, right, would be your a value, which would be exactly half of 24, which is 12 meters. So that's what a is, okay? And it's stretched in the x direction, so we're going to put 12 squared there. And then here, this is just from the center to your covertice here, so this is going to be b. So b will be 8 squared, okay? Now technically you could probably just leave it like that. If you want, you could also write it as x squared over 144 plus y squared over 64 equals 1. And all we had to do is write the equation, so we are good, all right? Now the next one, okay, is what's called a whispering gallery, okay? So if you have ever been to Grand Central Station, there is a whispering gallery there. What it is it's a gallery that's, it's like a hallway, if you will, in the bottom of Grand Central Station that has its roof, okay, or the top of it is shaped like an ellipse, okay? And I'll put on Schoology a really interesting video for you guys to watch if you'd like, okay? You don't have to. But basically what happens is, if you go to the Whispering Gallery, there is, if you stand at one of the foci here and you speak to the wall, it will bounce off, and then someone else standing at the other side, right, will hear you, okay? And that's because of the semi-elliptical shape of the roof, all right? So that's pretty cool. I believe there's another one in one of the buildings in DC, but this is the one that I've seen, okay? So it's pretty cool, and it totally works. I'll show it, like I said, I'll post a video. But that's because of the elliptical shape. So if you take a look here, a hole spans 120 meters in length, okay? All right, its foci are located 25 feet from the center. So here's our foci, here's our foci. This is 28 feet, okay? This is feet. 2. Sorry about that. That would be just silly if I'd used 2 different measurements. Okay, so if the foci are 28 feet from the center, how high is the ceiling at its center? So they're looking for this. So basically they're looking for B, okay? They've given you, if you look, C, because that's the distance from the center, right? 28 feet from the center. So that's C. And then they've basically given you B here because A here because A is the distance from the center to a vertice. And this has to be wider, right? That's the length here. So A is 60. So therefore, if I think back, when I'm trying to find A, B, or C, in an ellipse, that's going to be A squared minus B squared equals C squared, okay? So therefore, I'm going to do 60 squared minus B squared equals 28 squared, right? So then 28 squared minus 60 squared, right? If I bring this guy over, is B squared equals 2816, right? If I subtract that 60 squared over, then I square root that. Oh, whoops. And I get the square root of 2816, which is, B is approximately 53.06599, right? Dot, 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 dot. And so let's say I round, I think your book usually rounds to the nearest hundredth, so 53.07, and this is feet. So that's the height of the Whispering Gallery, all right? So that's what we're doing there, okay? So 2 different ways to ask you an elliptical word problem, all right? One where you have to write the equation, one where you have to find the B value. Now if we look at this one, okay, we have an elliptical garden. So what does it say? An elliptical shaped garden is surrounded by a wood walkway. Okay, so we have a garden. We have a walkway around it. Seems like that to me. The garden is 15 meters long and 8 meters wide. The walkway is 2 meters. Find the equation of the ellipse. Now, when they're saying 15 meters long and 8 meters wide, I'm assuming, right, they're telling me this is 8. And that is, right, 15. So we got that. The walkway is 2 meters. Find the equation describing the lift that includes both. Okay, so this is 2, 2, 2, and 2. So basically, right, if I think about my whole ellipse here, this is 8, 10, 12 is my total distance, right? That's my minor axes. So if my minor axes is 12, then that tells me B is 6, right? Because it's always half of that, all right? And then here, my major axes would be, what do we have? 15, 17, 19, okay? So therefore, half of 19, what's that, 9.5? So A is 9.5, okay? So therefore, now the way I drew it, okay, is I was thinking of this as the length and this as the width. I mean, I guess it kind of depends on the way you drew it. That makes most logical sense to me. But here, right, you have x squared plus y squared equals 1, right? Because I'm measuring everything from a center here, so I would imagine that's like my x and my y axes. Okay, so I haven't shifted the center at all here. So then, if I take a look here, I want to plug in, right? If this is my major axes, this would be 9.5 squared, right? And then this would be 6 squared, okay? If you thought of it the other way, like if this was a word problem on a quiz, and you thought of it the other way, I would take that the 6 and the 9.5 squared were opposite. There's a question like that on the worksheet for tomorrow, okay? Because I don't think it's as clear, so there might be 2 answers for one of the questions. And you'll see that on my answer key, okay? Lastly, an arch bridge over a highway is semi-elliptical. Okay, so I mentioned this yesterday. I'm gonna have to tell you what kind of shape it is. So it will say either parabolic or semi-elliptical, okay? So if you look here, we have this, which I know is an ellipse, right? It is 42 feet across, okay? The highest point of the arch is 14 feet above, okay? What is the maximum height to the nearest inch of a truck 8 feet wide that can fit? So assume the highway is 1 lane. Okay, so first we're gonna have to write our equation, which we can do in just a minute, imagining this is my x-axis, right? This is my y-axis. So we have a center at the origin, okay? And we have our b value, and then our a value would be half of 42, right? So if that's half of 42, what's that, 21? So that's 21, okay, feet. So if I write my equation, and then I'll get to the next part. Okay, so my equation here would be x squared plus y squared equals 1. The x-axis, right, that's where my major axis is, so that would be 21 squared. And then this guy would be 14 squared, right? And I have that. And you could just leave it in the squared form, that's fine. What is the maximum height of a truck that is 8 feet wide? Okay, so if I imagine this truck, this is a 1-lane highway. Here's the truck, okay? Boop, boop. There are the wheels. Wow, that's really bad. Okay, but you can just imagine the wheels are like here, you know, like it's a big truck, okay? So there's a double wheels, okay? The truck's going through. If it's 8 feet wide, we wanna know the height here. Now, I'm not gonna plug 8 feet into the equation here. What I'm going to plug in, because this is a single lane and I'm assuming to fit, he's gonna drive down the middle of it. This, right, height I'm looking for should be 4 feet from the center. So this is 4 comma something, okay? So I'm looking 4 feet from the center, so I'm gonna plug this in for the x value. So 4, and then what's the maximum height, right? To the nearest inch. So I'm gonna do that, okay? So I'm gonna plug in 4 for x. So this is gonna be 4 squared over 21 squared. That's y squared over 14 squared equals 1, okay? And then what you have to keep in mind is you're gonna bring this guy over, okay? So you're basically gonna subtract 4 squared over 21 squared to isolate the y squared over 14 squared. So now you'll have y over 14 squared equals, and then I'm gonna do this guy in my calculator, right? So this is gonna be 1 minus 4 squared divided by 21 squared. And that gives me 0.9637. I'm not gonna round that, okay? And then I'm gonna multiply both sides by 14 squared. And again, you could have squared these already, okay? And just use the numbers. I'm just leaving them in squared form, doesn't matter. So times 14 squared. And I get, oh, this should be y squared. Y squared equals 188.88. Okay, and then my last step is to square root that. And then I get y equals 13.74, blah, 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 blah. But that's in feet. So remember, we want to change this into inches. So if I take 0.74368542, whatever they show me, and multiply that by 12, that tells me that I have about 13 feet, and then that would be about 9 inches, right? I would round. And that okay? Sorry, that skirted right off the page, didn't it, okay? So the big thing to remember is I use parentheses around this because I left it in its squared form, all right? So you're gonna plug in for x because you know your horizontal distance. You just need to know how tall it is, right? The vertical. And then subtract that. You could also turn, like I said, put that into your calculator, get the decimal. Do not round at all at any point though, okay? So bring that guy over, right? Then you have y squared over 14 squared equals the decimal multiplied by 14 squared. That should become a larger number because then you'll square root and then you'll get 13.74, which is 13 feet 9 inches, okay? So there will be a couple on your homework where you have to plug in a value, okay? All right, I think that's it for elliptical word problems, okay? I think these are a little bit more straightforward maybe than the parabolic ones, okay? But you guys, you know, you'll see, all right? Give the homework a try, and early next week, okay, on Monday, I will be having a review session for the upcoming quiz, and then we'll have our quiz. I'll assign it on Monday, and it'll be due on Tuesday, okay? Then we'll finish up one small unit, and then we're done, all right? Hope you're doing well.